Hello everyone, welcome back to Knock Knock Air Education, and this is the third lecture on double integral. So today is going to be the last lecture where I am covering the basic concepts about the double integrals, and then from tomorrow we will start with the change of order of integration. But before starting the lecture, if you people remember, I have given a question to all of you as a homework, so let's discuss that and then we will move to a few more questions, because yesterday I told you that I will do few more questions for all of you so that you can get a better idea about finding out the limits of a double integral. Okay, so just this question: double integral xy x plus y dx dy over the area between y equals to x square and y is equals to x. So we have to find out the limit of this integral. So what we have to do is that we have to draw the region of integration. So what we will do, we will just draw this y is equal to x square and y is equal to x, and we will see the area bounded between these two curves, and that region is going to be the region of integration for this double integral. Okay, so let's just draw it quickly. And then here we have y-axis, then we have with us the x-axis, and then we have to draw again a straight line which is our y is equals to x. Okay, so this is going to be our line y is equals to x. Fine. And now what we have to do, we have to draw a parabola which is y is equals to x square. So all of us know that y is equal to x square is going to be an upward parabola which is going to be like this. So if all of you can see that our region of integration is the area bounded between these two curves, that is y is equal to x square and y is equal to x. So obviously this is going to be this area or this region of integration we are talking about. Okay, so in our yesterday's class I have told you that it is up to you whether you want to find out the limit of x in terms of y or the limit of y in terms of x, but just have a look in both the ways, that which way is giving the answer in a short period of time and in a easy calculation. Okay, so if you see here, suppose somebody wants to find out the limit of x in terms of y. So you will draw a strip which is parallel to x-axis, and from where to where it is going? It is going, because we have to go from left to right. So what it is going to be? It is going to be from x is equal to y to x is equals to root y. Why I am saying root y? Because you see, we have y is equal to x square, this parabola, right curve. So we will get x is equals to plus minus root y. But since we are working in the first quadrant, right, so we are going to choose what? We are going to choose x is equals to root y. So since we have to move from left to right, so the limit of x is going to be from y to root y. And now if we want to find out the limit of y, we have to go from bottom to the top. So the bottom point is 0, 0. So obviously the limit of y is going to be from 0. But what about this part? So this part is going to be what? The point of intersection between y is equals to x square and y is equal to x. So any point of intersection is going to satisfy both the curves, y is equal to x square also, y is equal to x also. So what we will do here? X square is equal to x. So now you take x common, we will get x minus 1. So see, from here we are getting 2 points, x is equal to 0 and x is equal to 1. Now you substitute either in y equals to x square or in y is equal to x. Once you will keep x equal to 0, you will get y equal to 0, and see here y is equal to x and y equal to x square are intersecting and we are getting 0, 0. You will keep x is equal to 1 here, you will get y equal to 1. It means this is our 1, 1. So what is the value of y? Topmost point, y is equal to 1. So the limit of y is going to be from 0 to 1. Now you keep the limits y to root y, and then from y is equal to 0 to 1, we have here xy, and then we have x plus y. This is x plus y dx dy. Okay, so now you integrate, and with respect to which variable you are going to integrate first? Obviously with respect to x, because the limit of x is in terms of y. So 0 to 1, and here you will deal y as a constant. So y, then this is going to be x square. On integrating, we'll get x cube by 3. Then we are getting over here y square, and x is going to be x square by 2. Now we will apply the limit x is equals to y2, x is equal to root y, and here we have dy. Okay, so now what it will be, 0 to 1 y, then here we have y by 3, and here we will be having y root y, then minus this is going to be y cube. Okay, then this is y square by 2, this is going to be root y square, that is y, minus we'll get y square, and this is dy. So now what we have to do is that we just have to integrate. So first collect the terms. This is going to be what? This is going to be y square and into root y. So the power of y is going to be what? 2 plus 1 by 2, that is 5 by 2 by 3. Then this is going to be y to the power 4 by 3. This is your y cube by 2. Then y to the power 4 by 2. So you can collect this 1 by 3 and 1 by 2 together. So now we will integrate this y to the power 5 by 2. So it is going to be y to the power 7 by 2. This is going to be 7 by 2. Here we will get 2 by 7. 3 was already there. Then this is going to be 1 by 3 plus 1 by 2. That is going to be what? 5 by 6. So this is 5 by 6. And once we will integrate y to the power 4, we will get y to the power 5 by 5. And then y cube by 2 on integrating, we will get y to the power 4 by we have 8, and the limit is from 0 to 1. So what we got over here is 2 by, this is 21, minus here this 5 got cancelled out. So what we got is 1 by 6, and here we got 1 by 8. So now you can solve this and find out what is going to be the answer. So this is the final answer for this double integration. Okay, so our work was to find out the limits which I have told you. But in the same question, suppose if somebody wants to find out the limit of y in terms of x, then that is also very simple. Okay, just see here. Here we have y is equal to x square, and then here we have a line, our y is equal to x. Okay, so this is our region of integration. So if someone wants to find out the limit of y in terms of x, he or she will draw a line which is parallel to y-axis. So now we always move from where to where? Bottom to top. So bottom curve is what? Y is equal to x square, and the top curve is y is equal to x. So bottom to top we have to go, the limit of y is from x square to x. And since it was 1 comma 1 and it was 0 to 0, so we have to move from left to right. So the leftmost point says that x is equal to 0, and the rightmost point says that x is equals to 1. So this is. So if you are going to keep this limits also, you are going to get the same answer that we were getting in this form where we have kept the limits of x in terms of y. Okay, so this was our homework question that I discussed just now. Now we will do few more questions so that we can have a better practice, and in future once we will do the questions based on change of order of integration, area, we are able to find out the limits without any problem. Okay, so let's do few more questions. So the next question that we have to do today is we have to evaluate this integral y dx dy over the area between the parabolas. And what is that? Y square is equals to 4x, and you have x square is equals to 4y. Okay. So first what we have to do is that we have to draw our region of integration. Once we will draw it, then we have to find out the limits. Okay, so let's just quickly draw the region. So here is our y-axis and this is x-axis, and now we will draw our parabolas. So the parabola that we have is, one is y square is equals to 4x, which is like this, and the another one is x square is equals to 4y, that is our upward parabola. Okay, so let's draw both of them. So this is going to be our parabolas. Okay, now you see this is the area bounded between both the parabolas. Okay, this is your what? This is your x square is equals to 4y, and here you have y square is equals to 4x, and this is the area which is being bounded between both the curves. So this is our region of integration. We have to integrate this integral over this domain. So in this case, see one thing, if you want to find out the limit of y in terms of x, then what you will do, you will just simply draw a strip which is parallel to what, y axis. So here you see, this is your x square is equal to 4y, so you will get y is equal to x square by 4, fine. And this top curve is what, y square is equal to 4x, but since you want the value of y, so it is going to be y is equal to plus minus root 4x, but since we are in the first quadrant, so we'll take positive value, so that is going to be root 4x, and which is going to be 2 root x. So we got the value of y, what, y dx dy, and we got the limit of y as from bottom to top, that is from x square by 4 to 2 root x. Then again we want the limit of x, so we have to go from left to rightmost point of the domain. So for that we need our point of intersection. So now what we will do, we will just find out the point of intersection. So we have y square is equal to 4x. Okay, so now we'll just keep the value of y from here. Why? So it is going to be x square by 4 whole square, and this is going to be 4x. So this is x to the power 4 minus, this is going to be your 4 cube x, fine, because it is 4 square and into 4. So now you take x common, you will get what, x cube minus, here you are getting 4 cube equal to 0. So one point you are getting is x is equal to 0. And now what you will do here is that you will just break them in the factors. You will get x is equal to 4, sorry, you will get here x is equals to, because once you will break it in this form, x minus 4, because you are applying the formula a cube minus b cube, so a minus b, a square plus b square plus ab, so you will get from a minus b, that is from x minus 4, you will get x is equals to 4 as one of the point. Now what you have to do is that you can either keep it in y square is equal to 4x, or you can keep it in x square is equal to 4y to find out the value of what, value of y. So do one thing, do keep it in x square is equals to 4y. So what you are getting, 4 square by 4 is equal to y, because x is 4. Okay, so when x is 4, so what you will get, you will get y is equal to 4. So this point of intersection is your 4 comma 4, and once you will keep x is equal to 0, so see you are getting y equal to 0, that we have already written over here 0 0, and this is 4 4. So what is going to be the limit of x from left to right, that is from 0 to 4. And even if you have any doubt that the point of intersection that you have evaluated is right or wrong, so do one thing, let's just see that this point satisfies the curve or not. Keep x is equals to 4 over here, so it is going to be 16, you are getting y is equal to plus minus 4, we are in the first quadrant, we will get y equal to 4, and that's what we have written. If you want to substitute it here, you substitute it here, x is equal to 4, so 4 square is equal to 4y, we will get y equals to 4. Automatically it is coming out to be 4, so that means we have evaluated the point of intersection correctly. Okay, so we have to solve this integral. Which integral? From x is equal to 0 to x is equal to 4. Then we have x square by 4 to we have 2 root x. Okay, then what we have is y dx dy. So first we will integrate with respect to what? With respect to y, we will get y square by 2, and here we have x square by 4, then we have 2 root x dx. So what it will come? 0 to 4, 1 by 2, y square is your what? 4x, because 2 square into x, 4x minus, this is going to be x to the power 4 by, we will get 16, and this is going to be dx, because we have to square x square by 4. So what we will get, see here, you will cancel out this 4 by 2 times, and on integration we will get x square, so again that 2 will also get cancelled out. Then here we will have x to the power 5 by 5, and 16 into 2 we have 32, and then we have to apply the limit from 0 to 1. So what we are getting is 1 minus 1 by 5 into 32. So this is the answer that we are getting. So we just solve it and see what final answer we are getting. So just what we'll do, this is going to be your 160, and then 160 minus 1, that is 159 by 160. This is the answer that we are getting for this question. Okay, So this is the answer for this question. Okay, just 1 minute. This limit was from 0 to 4. Fine. This limit was from 0 to 4. So what we will do here is that, sorry for the calculation, it was from 0 to 4, so we will solve it accordingly from 0 to 4. So it is going to be 16. Then here what do we have is 4 to the power 5. Okay, and it is by 5 into 32. No problem. So do one thing. What we can do here is that we can make this calculation a little easier. We'll keep it 4 square only. Okay, so now what we will do, we will take 4 square as common. So it is going to be 1 minus 4 cube, and this is your 5 into 32. So here also we can just do a little calculation. 4 cube by 5 into 32. So we know that this is 4 into 4 into 4 divided by 5 into 32. So this is 16. It is 2 times 32. Then here we got 2. So the overall expression what we got is 2 by 5. So this is your 4 square, then 1 minus 2 by 5. So it is going to be what? 4 square into 3 by 5. So 48 by 5. This is the answer that we are getting. Okay, so this was a calculation mistake. The limit was from 0 to 4, not from 0 to 1. That's why we were getting something else. Okay, but the answer is 48 by 5. Fine. So let's move to another question, and we will see how we can find out the limit. But before that, see one more thing in this question, that if somebody wants to find out the limit of x in terms of y, then what we will do, we will just simply draw a strip which is parallel to what? Which is parallel to x axis. So left curve is going to be what? This is your y square is equal to 4x. So x is going to be from where to where? Y square by 4. And in this case, this is x square is equal to 4y. So what we will do, x is equal to 2 root y. So it can simply be done like this also, from left to right, that is from y square by 4 to 2 root y. And the limit of y, we can keep what? We can keep the limit of y as y is equal to 0 to 4, that is from bottom to top. And we can keep this at y dy dx, or you can just keep dx dy and keep the limit like this. Okay, so this was question number 2 that we did today. Let's proceed to question number 3. So the question number 3 that we have is, we have xy by square root of 1 minus y square dx dy. And then what we can do, they are saying that we have to integrate this over the positive quadrant, of circle. X square plus y square is equal to 1. Don't worry, these are just the basic questions. They will help you out in actually finding out the limits, because they will help us in solving the questions which are related to finding out the area and then change of order of integration. They will help us over there. Okay, so if you are able to find out the limits here, but if you are finding out that the calculation is little lengthier, don't worry. Later on we will just learn the ways how to make our integrations a little simpler. Okay, so suppose this question we are doing, if you will solve it in terms of xy Cartesian, it will become a little bit difficult for you. But later on, once we will study polar form, these questions once you will revise and you will try to solve them with the help of polar form, it will become easy for you. So if you are facing some problem in calculation part, just practice questions a little more, and as soon as this course will proceed, we will learn many more concepts which will help you out in solving the calculations a little in a easier way. Okay, so this is our question, and we have to find out what? We have to find out the limits. So they are saying that we have a circle, x square plus y square is equal to 1, and over the positive quadrant we have to find out this double integral. So what we will do is that we will just draw the circle. Okay, and now what we will do, we will just draw our x-axis and y-axis. So let's just draw them. I hope they are visible to all of you. Okay, so this is going to be our x-axis. So now what we have to do is that we have to just work in the positive quadrant, that is we have to work in this first quadrant only. So if somebody wants to find out the limit, what we will do? We will just simply do what? Draw a strip either parallel to x-axis or parallel to y-axis, whatever we want. So suppose this time I want to find out the limit of y in terms of x. What I will do? I'll just simply draw a strip which is parallel to y-axis. And also remember one thing, that even if you draw this strip anywhere in this region in the first quadrant, they are always going to be from where to where? From y is equal to 0 to y is equal to square root of 1 minus x square. Why? Because we have x square plus y square is equal to 1. So we'll have y is equals to plus minus square root of 1 minus x square. But since we are in the first quadrant, we will choose the positive value of y. Okay, so we got the limit of y, that is y from 0 to square root of 1 minus x square. And since it's a unit circle, the radius is 1. So this point is 1 comma 0. This point is your 0 comma 1. And this point is our 0 0. So we'll go from left to right. Left to right, what we are seeing is that the limit of x is from 0 to 1. Write it down like this, 1 minus y square, and here we have dx dy. Okay, but suppose somebody wants to find out the limit of x in terms of y, then what you will do? You will draw a strip which is parallel to x-axis, and in this region anywhere you can draw it. So this is what? This is y-axis, x equal to 0, and again from the same calculation, what you did? You got x is equal to plus minus square root of 1 minus y square. So since we are in the first quadrant, we will choose plus square root 1 minus y square. So x is going to be from where to where? 0 to 1 minus y square. And then you see from bottom to top, here we have y equal to 0, and here the topmost point we have y equals to 1. So y is from 0 to 1. We have xy square root of 1 minus y square dx dy. For the time being, don't solve this integral. If you want to solve, you can solve it, but it is going to be a quite lengthy for all of you. That's why I'm telling you, don't solve it for now, because we are going to solve this question again somewhere once we will study polar form, because polar form reduces our time and it makes our calculation part a little simpler. So if we will solve it in Cartesian form, it will take a lot of time and there are chances that we can do mistakes. But once we will solve this question with the help of polar form, we'll get the answer within a very short time. Okay, so just wait for the session where I will teach you the polar form, and then it will help you out in finding out the limits in polar form, and that will give you a calculation a little early. Okay, so I think these many questions are sufficient for you to understand the basics of the double integrals, and just watch these 3 lectures thoroughly so that you can understand the basics, because I will use it in the upcoming sessions. So the next session that I will be taking is going to be very important session, and I'll take it on change of order of integration. So make sure you finish these 3 lectures before you start with the change of order of integration, and you have to understand change of order of integration. Why I am saying is that if you are going to see the question paper, previous year question papers, you will see every year they ask a question from change of order of integration, either in section A or in section C. So for you it is very important to understand the topic, because even 1 or 2 marks makes a huge difference in your ranking. And even if you are not able to just cross the cutoff, so if you are just gaining 1 or 2 marks which are already known that okay, we will get a question from here, so obviously why not to cover that topic. Okay, so that's it for today's session, and now I'll take class on change of order of integration. But before that, please watch these lectures as soon as possible, so that you can daily watch these lectures and you are up to date. Okay, so that's it for this session. Thank you so much.